Hi everyone. In this video, I will explain a numerical problem on this Gauss-Seidel load flow method with PQ and PV buses. Already we have discussed the problem on with only PQ buses. Now we will see this problem, that is using Gauss-Seidel method with PQ and PV buses. This is the problem given. Here what they have given, see that. For the system, for the sample network given below, they are asking to find Q2, delta 2, V3 and V4 at the end of the GS first iteration, Gauss-Seidel first iteration. For that they have given two conditions for the reactive power. First one is 0.2 less than or equal to Q2 less than or equal to 1, and second one is in between 0.25 and 1. They have given bus data and line data. This is the bus data they have given. They have given real and reactive powers, voltage magnitude, and what is the type of the bus. And they have given line data also. In that line data they have given this conductance and susceptance. That means directly they have given the admittance value. Okay. Now, as per the problem, now first we need to calculate Q value. For that, first we need to calculate Y bus matrix. Now this is the our required Y bus matrix that we have calculated from the given data, that is G and P values they given, that is conductance and susceptance values directly. Now as per the network given, this is the Y bus matrix. Now this Y bus matrix we need to convert all these values. See here in this Y bus matrix all these values are in rectangular form. Now we need to convert them in polar form also. I will tell you why to calculate, why to convert these rectangular forms to polar form. I will tell you. First let me write the Y bus matrix in polar forms. So this is the Y bus matrix in all elements in polar form. Next, see what is required here. Now we will see the required data that is given in the problem. First, slack bus data. What they have given in slack bus? They have given that slack bus means that is a bus 1, first bus. They have given the voltage value, that is 1.04 at an angle 0 degrees. So now this will be the same for all the iterations, because slack bus is that is common, a reference bus. So now whether it is first iteration or 0th iteration or second iteration, whatever, this is 0, first iteration and second iteration, whatever, this is in all the iterations, this will be the common, that is the given value 1.04 at an angle 0 degrees. Now PV bus. What they have given? They have given the real power value, P2 value, because PV bus, second bus is the PV bus they have given. Now for that P2 they have given, that is 0.5 per unit, and voltage value also they have given for the PV bus, because for PV bus P and voltage magnitude are the specified values. known values. Those values they have given. And as per the assumption, as they have not given that angle specifically, that is actually 1.04 at an angle 0 degrees. Next, PQ buses they have given bus 3 and 4 are the PQ buses. That data also will collect. Here P3 for bus 3 they are given real power, that is P3, that is -1 per unit. As this is the PQ bus, they have given both real and reactive powers, because for PQ bus we know that real and reactive powers are the specified values, right? So Q value is 0.5 per unit. Similarly, for PQ bus, that is P4, 0.3 per unit. Q4 is minus 0.1 per unit. This is the data they have given actually. Now already we need to assume that is as per the voltage profile, flat voltage profile. We need to assume the values. Let us assume flat voltage profile for buses, for all PQ buses. For slack bus and PV bus not required actually, because already voltage value is known value for both the slack bus and PV bus. Already they have given, that is 1.04 at an angle 0. Now for these two buses, that is bus 3 and bus 4 PQ buses, so now we need to assume this flat voltage profile, that as per that flat voltage profile we will see that how it will. So that is V3 is equal to 1 plus J0, that is equal to V4. So from this we can write V3, magnitude of V3 initially will take, and similarly that is equal to magnitude of P4 0, that is initially we are assuming as 1 per unit, and their angles also delta 3 0, that is equal to delta 4 0, that is equal to 0 degrees. Now as per the problem we need to calculate the reactive power at bus 2, that is PV bus. PV bus, P and V are the specified values and Q and delta are the unknown values. We need to calculate them. First we will calculate the Q value as per the data given and assumptions. First we will calculate the Q values. We know that the static load for equation, real and reactive powers already we have derived. So now from that we will take the Q equation, equation Q. See here, that is QP at K plus 1 iteration. Initially that K is equal to 0, that we know that is minus sigma Q is equal to 1 to N VQ, sorry VP, VQ, YPQ sin theta PQ plus delta Q minus delta. This is the equation for Q. Now we'll calculate the Q value for second bus, that is Q2, where K is equal to 0 plus 1, that is Q2 at 1, first iteration, Q2 1. Now minus sigma Q is equal to 1 to number of buses they are given, 4 in the problem. Now as it is, write the formula Vp Vq Ypq sin theta pq del q minus del p. This is Q2 1, that is by the end of first iteration reactive power value. Now we will calculate that as per the given data. Now that is equal to, we will expand all terms, that is Q is equal to 1 to 4, where here Q value is 1 comma 2 comma 3 comma 4. We will substitute all this. Now minus commonly it will be there, where P is equal to, see here P is equal to 2, K is equal to 0. This you need to substitute already. K value 0 have substituted. Now we'll substitute the value of P is equal to 2 and Q value 1, 2, 3, 4. Okay. Now V2 Vp, here Vp means P is equal to 2. V2 Q, here first you are substituting Q is equal to 1, that is V1 Y21 sin theta 21 plus Q is equal to 1, del 1 minus del 2, plus next term is when Q is equal to 2. Okay, that is mod V2, again Q is also 2, Q is equal to also 2, V2 Y22 sin 22 plus del 2 minus del 2. Next third term is plus V2, here now Q is equal to, here now Q is equal to 3, Y23 theta 3 plus del 3 minus del 2. Now substitute Q is equal to 4, V2 V4 Y24 sin theta 24, okay, del 4 minus del 2, close the bracket. Now these are the 4 terms after substituting P is equal to 2 and Q values from 1 to 4, 1 comma 2 comma 4. Okay. Now as per the given data, we know that delta, see here these values, delta 1, delta 2, delta 3, delta 4, all are zeros. Now 0 minus 0, that is 0, So no need to consider that term. So now here we are simplifying this equation as that is equal to Q21 minus of V2 V1 Y21 sine of theta 21, okay, plus V2 again V2 Y22 sine of theta 22 plus V2 V3 Y23 sin theta 23 plus V2 V4 Y24 sin theta 24. Okay, this is the final formula. Now a simple thing is we need to substitute all the values. All values are readily available from the data that I have already given. Now substitute those values and you can calculate the Q value. I am substituting. See here, you know that V2 value, that is PV bus PV value they have given, that is 1.04, and V1, that is slack bus value, that is also 1.04. Y21 already we have calculated, and here this theta 21 is the Y21 angle. Already we have converted the rectangular form Y bus matrix into polar form. So for this purpose only we have calculated, we have converted those rectangular forms into polar form. Okay, are you getting my point or not? Now here Y21 6.32. If you want, you can refer back the Y bus matrix into sin theta 21 is 108.43 degrees plus this one. Now this term V2, that is PV bus value 1.04, again 1.04, Y22, that is 11.59 sin at an angle minus 71.55 degrees 71.55 degrees, that is Y22 value. Now plus this term. Now substitute the values for this term. We know that V2, that is PV bus 1.04, here V3 is the PQ bus, so that is as per the flat voltage profile value is 1. Substitute 1. V23, that is 2.1 sin theta 23, that is 108.52 plus last term, this term V2 again PV bus 1.04, V4, that is as per the flat voltage profile 1, that is PQ bus, and Y24, that is 3.16 sin of theta 24, that is 108.43 degrees. So after substituting Q21 value will be 0.215 per unit. This is the Q1 value they have given. Now we have calculated from the data Q1 value. Okay, is it clear as of now how we have calculated, how to calculate this Q value for bus 2 at the end of first iteration. Okay. Now here they are given two conditions. If you consider first condition, that is case 1, what is that? What they have given? They have given Q limits. They have given 0.2 less than or equal to Q2 less than or equal to 1. In this condition, you have to check the calculated value. What is the calculated value? Actual calculated value, that is Q21 0.215 per unit. Now check with this condition. Now is this value is within this condition or not? Yes, that is 0.215, that is more than 0.2 and that is within 1, value 1. Now the calculated value is within the condition, within the limits. So now we write here, that is calculated value Q21, that is equal to 0.215 per unit is within the limits, reactive power limits. So as per this, already we have discussed this point in theory, that is, if the calculated value is within the limits, so now treat bus 2 as PV bus. Treat bus 2 as PV bus. Okay, because why we need to consider as such as PV bus? Because the calculated value of Q is within the limits. Now PV bus, as you are considering that bus 2 as PV bus, okay, what we have to calculate here? PV bus, for PV bus already V is known, they are given, that is 1.04. Okay, that no need to calculate, only angle we have to calculate here. Voltage angle you have to calculate here if it is PV bus, or otherwise if it is PQ bus, we have to calculate, we need to calculate, and delta also we need to calculate. But here we are treating bus 2 as PV bus, so already V value is known value specified, that is 1.04. Just now we need to calculate angle angle of voltage, bus voltage. Okay, so for that purpose, anyways, we need to calculate the bus 2 voltage value, as per the formula. So after calculating the bus 2 voltage value, just we have to take only angle of that value. Okay, I will explain you how it is. See, now what is the formula for the bus voltage? Already we have derived this equation. Vp k plus 1 is equal to 1 by pi pp minus q p k plus 1 by Vp k conjugate minus sigma q is equal to 1 to p minus 1 ypp, sorry, ypq vq k plus 1 minus sigma q is equal to p plus 1 to n y pq vq k. This is the formula for calculating the bus voltage. Now our P value is 2 because we need to calculate the voltage of bus 2. Now see here, P is equal to 2 here and K is equal to 0. Now substitute this. Now V2 K plus 1, that is 0 plus 1, that is 1, V21 is equal to 1 by Y PP 2 because P value is 2. Substitute P as 2, that is P2 minus Q21 by V2 0, K is equal to 0, conjugate minus sigma Q is equal to 1 to P minus 1. P is equal to 2 here. See here, this is P is equal to 2 here. So P minus 2, that is 2 minus 1, that is 1. 2 minus 1, that is 1. Now Y PQ VQ K plus 1 is equal to 1, that is 0 plus 1, 1 minus sigma Q is equal to P plus 1, where P is equal to 2, 2 plus 1, 3, Q is equal to 3, 2n, that is 4. Total number of buses 4. Y PQ VQ 0. Now substitute the values. Then before substituting values, this we will elaborate this equation clearly. Y22 P2 that is all this you can keep J values here, that is P minus J, it is missed, P minus J, P minus J Q 21 minus Y21. See here, Q is equal to 1, 1 to 1, Q is equal to 1, you need to substitute. P is equal to 2, anyways here this is P is equal to 2. So now Y21 V121 V11 minus here Q value is 3 to 4, that is Q is equal to 3 comma 4. First substitute 3 and then 4. Now two terms you will get, that is for first when Q is equal to 3. Now YPQ, that is P is equal to 2, Q is equal to 3, P 3 0 plus Y 2 4. When Q is equal to 4, substituting V 4 0. Okay. Now substitute all the values here. V2 0 conjugate is missing. Okay. Now substitute all the values. Now substitute all the values, that is 1 by Y22, that is 3.67 minus J11. Here P is 0.5, they have given from the table in the problem. P2 value is 0.5. J Q21 already we have calculated value, that is 0.215. 0.215 by V20. V20, that is bus 2 value, they have given 1.04 at an angle 0 degrees, that is conjugate, minus Y21 from Y bus 2 plus J6 2 plus J6 into V11. V11, that is V1 means slack bus voltage 1.04 at an angle 0 degrees minus these values now we are substituting. Minus Y23 is minus 0.67 plus J2 V30 as per the flat voltage profile 1 at an angle 0 degrees, okay, plus now I am substituting for this, that is plus minus, because this minus into this one minus into plus minus, so minus Y24 value is minus 1 plus J3 at an angle 1 at an angle 0 degrees, that is V4. Okay, after substituting all this, after calculating the value, finally we will get V2 value, that is V21 value as 0.9874 at an angle minus 18.1 degrees. Now here this value, whatever the value is there for V2, this is not required for us. Already they have mentioned, they have given for second bus, that is PV bus, because we are considering this bus as PV bus only, because the Q value, calculated Q value is within the limits. That's why we need to treat this bus 2 as PV bus only. So for PV bus, V is specified, V is known value, that is 1.04. Only this angle is not specified, that we have calculated now. Only consider this, and instead of this value, take that value, actual value 1.04. okay, now our actual V21 value will become 1.04 at an angle minus 18.1 degrees. That is in polar form. If you write it in rectangular form, 0.989 minus J.32 per unit. All these values you can calculate with the calculators. You can check whether these are correct or not. Okay. This is calculation of V21, that is V2 value at the end of first iteration. So 2 points for Q we have calculated, and we have got the value, we have checked with the condition, so that is condition satisfied, that is within the limits. So now we are treating that bus as a PV bus. So for that PV bus V is specified, then we need to calculate the angle, voltage angle. So for that we are calculating all complete voltage value. This value you have got, but this is not required, only 1.04 we have to consider, and angle as such you have to take this. So finally we got this value. So now V2 calculation is over. Okay, now see this, what is remaining in the problem? We need to calculate V3 and V4 values also. Now calculation of V3 and V4. Now we have the formula, V value, V equation, that is now V31 we have to calculate at end of first iteration. That's why Now here P is equal to 3 and initially K is equal to 0. Now V31 is equal to, substitute in the formula, Y33 P3 minus J Q3 V3 0 conjugate. Here P is equal to 3 and P is equal to 3 and here K is equal to 0 conjugate minus sigma Q is equal to 1 to P minus 1, that is 3 minus 1, 3 minus 1 YPQ VQ VQ, what is that? K plus 1, K plus 1 is 0 plus 1, that is 1 minus sigma Q is equal to P plus 1, that is 3 plus 1 to 4 number of buses Y PQ VQ 0. Okay, is it clear? In formula we have substituted the P value and Q values. Now just again we will detail this, we will elaborate this in detail. 1 by Y33 P3 minus JQ3 by V30 conjugate minus, here Q is equal to 1 to 2, Q is equal to 1 to 2, that means Q value is 1 comma 2, Q value is 1 comma 2 and 1 and 2 1. So these values you need to substitute first with 1 and Q is equal to 1, that is Y P is equal to 3 P1, that is Y31 Q is equal to 1, we are substituting now, Q value 1 you are substituting. Now Q1 1 plus, now Q is equal to 2, you have to substitute. Okay, Y32, where 3 is equal to, that is the P value, Y32 V2 1 V2 1 close the bracket minus this term, that is Q is equal to 4 to 4, that means Q is equal to 4 only one value, that is Y34 V40 V40. Now substitute all the values. 1 by Y33 is 3.67 minus J11 P3 value. See in the table they are given in the problem, that is minus 1 minus JQ3 also they are given 0.5 by V3, that is as per the flat voltage profile V30 is 1 at an angle 0 conjugate minus Y31 from Weber's matrix minus 1 plus J3 into V11 slack bus voltage 1.04, that is minus of this minus here and again minus this term you are representing now. Y32, that is minus 0.67 plus J2 into V21, this value already we have calculated, this value is the V2 value, substitute as such, that is 0.989. V21 already we calculated now in previous step, that we are substituting 0.989 minus J 0.32 J0.32, that is V21 value. Now last term we are expanding, that is minus Y34, that is minus 2 plus J6 into V4 as per flat voltage profile 1 at an angle Z, that is 1. Okay. After simplifying all these values, now again after simplifying all these values, now see here, C is equal to 1 by 3.67 minus J11 minus 1 minus J0.5 minus of minus 1.04 plus J 3.12 minus of minus 0.02 263 plus J 2.1924 minus 2 plus J6. Finally, V31 bus 3 voltage after at the end of first iteration is 1.0226 minus J 0.1536, that is equal to 1.034 at an angle minus 8.54 degrees. This is the value of V3. And another one is there that is remaining in this problem, that is V4 value you have to calculate. What is that? V4 value you have to calculate. Now V4 1, that is V4 K plus 1, that is 0 plus 1. Now here P is equal to 4, P is equal to 4, K is equal to 0. Now P41, that is equal to 1 by Y44 P4 minus JQ4 V40 conjugate minus Q is equal to 1 to P minus 1, that is 4, P is equal to 4, 4 minus 1, that is 3 YPQ VQ K plus 1, that is 0 plus 1 1, and another one is Q is equal to P plus 1. Another term, if you want to expand here, another term is Q is equal to P plus 1, P is equal to 4, 4 plus 1 5, that does not exist because total number of buses are 4 only. But here if you want to calculate Q is equal to P plus 1, yes, see here another term, that is sigma Q is equal to P plus 1, that is equal to 4 plus 1, that is equal to 5. Q is equal to 5 is not exist because total number of buses are 4 only. That's why don't consider that term, that is not required. Stop here. Now substitute the values. 1 by Y44, just expanding in detail, P4 minus J Q4 pi P40 conjugate minus Y41 V1, this one. P is equal to 4, Q value 1 comma, see here Q is equal to 1 to 3, means that means Q value 1 comma 2 comma 3. You need to substitute 1, 2 and 3 terms you will get here, that is Y41 V11 plus Y42 V21 plus Y43 V31. Now substitute the values 1 by 3 minus J9. P4 is 0.3, they have given the problem. Q4 is 0.1. V4 as per the voltage profile 1 at an angle 0. Conjugate minus Y41, see here, Y41 and V11. Y41 is 0. This value is 0. That is for as per the Y bus matrix, admittance matrix. So this is 0 minus Y42 minus 1 plus J3 into V21. Already we have calculated, substituted 0.989 minus J 0.32. Okay, this value V21. Close. Next one minus of, because this minus will go inside, so minus of V43 from Y bus matrix minus 2 plus J6 into V31. This value, see here, this value we have to substitute this value. Now that is 1 minus 0.225 minus J 0.1535. Okay, finally you will get that V41 is 1.03 minus J 0.1823, that is equal to 1.047 at an angle minus 10.03 degrees. This is in polar form, this is in rectangle. This is the case 1 as per the condition they have given it. As per the condition they have given, that is Q value condition they have given, limits they have given, Q limits they have given. We have checked that already. This is the procedure for Gauss Seidel load flow analysis method with PV and PQ buses. Now we'll see the second case. That is, what is the case? Case 2. Case 2 is the given Q limits 0.25 less than or equal to Q2 less than or equal to 1. This is the second condition again. But our, what is the calculated value? Q21 value 0.215. Now tell me, is this value in limits or not? Within the limits or not? No, because this 0.215 is less than this. That is less than Q2 minimum value. So now in this condition, what to do? What is the theory there? Already you have discussed, I have explained you. So if the calculated value is not in the limits, if it is less than the minimum value, then consider our Q21 value as this minimum value, that is 0.25 per unit. 0.25 per unit. And another point also there, if this calculated value is not within the limits, and then if it is less than the minimum value, consider that Q21 has minimum value, that is 0.25. This value as such you have to take 0.25 and treat that bus as PQ bus. Treat that bus as PQ bus. Okay. Treat that bus as PQ bus. So now as you are considering that bus as PQ bus, here V is not known and delta, that is del, angle of voltage, also not known. So we have to calculate both V and delta value. So now we will calculate first V value for bus 2, that is V21 we have to calculate. Just once again we will recall the formula, that is Vp q plus 1, that is equal to 1 by y Pp minus j Qp k plus 1 by Vp k star minus sigma is equal to 1 to p minus 1 ypq vq k plus 1 minus sigma q is equal to p plus 1 to n ypq vq okay. So here we may get one doubt here, that is here for this y we are writing, qp k plus 1, because here already have calculated this value qt value at the iteration 1 k plus 1, this is k plus 1 is 0 plus 1 already have calculated that value we are considering here. That's why here I am writing qp k plus 1. Don't be in confusion, right? Don't be in confusion. qp k plus 1 is for that purpose. Now you know that p is equal to 2, k is equal to 0. That is v21 is equal to y22 P2 Q21 V2 0 conjugate sigma Q is equal to 1 to 2 minus 1 1 y PQ VQ K plus 1, that is 0 plus 1 1 minus sigma Q is equal to P plus 1, that is 2 plus 1 3 N is equal to 4 y PQ VQ K is equal to 0. Okay, it's clear. Now 1 by y22 P2 Q21 V2 0 conjugate. Here Q is equal to 1 to 1, only one value is there. Now y21 V11 y21 v11 q is equal to 1 only, minus here q is equal to 3 to 4, that is 3 comma 4, q is equal to 3 comma 4, two values have, two terms you will get here. Now y23 v30 y24 v40. Okay. Now substitute the values. 1 by 3.67 minus j11 0.5 minus j.25 by 1 at angle 0 degrees conjugate minus y21 2 plus j6 v11 that is slack bus 1.04 at an angle 0 degrees, okay, minus this term I am writing y23 minus 0.67 plus j2 v30 that is as per the flat voltage profile 1 at angle 0 degrees okay, and then next this term I am writing minus of minus 1 plus j3 v4 again 1 at an angle 0 degrees. Okay. After substituting, our v21 value is 0.9424 minus j.3062 that is equal to 0.99 at an angle 0.99 at an angle minus 18 degrees. This is V2 value. Similarly, we need to calculate remaining values. Already we have got the V2 value and we have got the del 2 angle also. This is the del 2, this is V2. As per the question, already we have calculated Q value, V2 value, delta value. Now V3 and V4 you have to calculate. V3 and V4. Now V3 1 is equal to 1 by y33 and remaining is simple. You can do that. V3 minus Q31 by V30 conjugate minus sigma Q is equal to 1 to P minus 1. P minus 1 minus 2 minus 3 minus 1 that is 2. Q is equal to 1 to P minus 1 that is 3 minus 1 2 3 minus 1 that is equal to 2 y PQ VQ dash minus Q is equal to P plus 1 that is 3 plus 1 4 to 4. Okay, Q is equal to P plus 1 that is here P is equal to 3, here this is P is equal to 3, K is equal to 0, K is equal to 0. So then P plus 1 minus 3 plus 1 that is 4, 4 to 4, y PQ, VQ 0. Now after substituting here 1 by, after expanding this 1 by y33, P3, Q31 by P30 conjugate minus here Q is equal to 1 comma 2 values we have, so we will get 2 terms we will get 2 terms that is y31 because P is equal to 3 y31 first we are substituting 1 P1 V11 plus y32 V21 minus here this is Q is equal to 4 to 4, only one term we will get, Q is equal to 4 that is y34 V40. Now after substituting all the values we will get this V31 value as 1.014 minus j.1511 that is equal to 1.025 at an angle minus 8.476 degrees. This is polar form, this is the rectangular form for the V3. Okay. Now finally last one is, that is calculation of V4. V4 1, that is equal to K is equal to 0, P is equal to 4 by, now 1 by Y44, 1 by Y44 1 by Y44 P4 minus Q4 1, that is can keep J here, by V4 0 conjugate minus Q is equal to 1 to P minus 1. Q is equal to 1 to P minus 1, where P is equal to 4, 4 minus 1, 3. Y PQ VQ K plus 1, that is 1. And then next term is sigma Q is equal to P plus 1, that is 4 plus 1, 5, not exist. So close this. That is not required. Now 1 by Y44 P4 minus J Q41 J Q4 J conjugate minus here Q is equal to 1 to 3, that is 1 comma 2 comma 3. Now Y41 V11 Y42 V21 Y43 V31. Okay, substitute all the values. 3 minus J9 P4 they have given 0.3 minus Q4 0.1. This is flat voltage profile 1 at an angle 0 degrees conjugate minus Y41 minus 1 plus J3 V11 already V11 value that is Y41 actually, that is 0, sorry, this one, this is 0, this is 0, this one we are now, this one, this is writing 1 plus J3 V21 already we have calculated 0.942 minus J 0.306 minus this term now Y43 minus 2 plus J6 V31, this one already we have calculated, this one is substitute this value, now that is 1.014 minus J 0.1511, sorry. Okay, J5 1. Now our V41 equal to 1.01 minus J 0.1761, that is equal to 1.025 at an angle minus 9.88 degrees. This is polar form rectangular, that is for V4. This is the problem for Gauss Seidel load flow method with both PQ and PV buses, including both PQ and PV buses. Here one note, very important note that we need to consider is, in problem they have given Q limits. If any problem is not having any Q limits, but they don't give any Q limits, then no need to check the violation of Q. Directly you can calculate Q value, then you consider that Q value as our required Q value. Okay, so I hope this is clear. This is the numerical problem solving on our Gauss Seidel load flow analysis with PV and PQ buses. Thank you.